Hi, you guys. I hope you're having a good day. Today, I want to go through our PowerPoint with you. I'm using Screencastify, so hopefully you can see my face and we can walk through the PowerPoint together. And I will try to explain stuff as we go so that this material is a little bit easier to grasp. So this is the second PowerPoint in our stoichiometry unit. If you recall from yesterday, um, you learned about mole to mole ratios. So as you look at the coefficients in a chemical equation, you can equate those directly to moles. And the ratio of them, of one reactant to the other reactant or one reactant to product, you can use those coefficients to come up with conversion factors, which we call mole ratios. So if you remember correctly, I think yesterday our example was we were using the equation that you have nitrogen gas and hydrogen gas, and it was making ammonia. Um, and you had some mole ratios in there. So for every um, 1 mole, I think it was every 1 mole of nitrogen gas and 3 moles of H2 gas, right? Then you would end up with 2 moles of ammonia from that. And so you had those ratios. You had for every 3 moles of hydrogen gas, you produced 2 moles of ammonia, or for every 1 mole of nitrogen gas, you produced 2 moles of ammonia, or for every 1 mole of nitrogen gas used, you used 3 moles of hydrogen gas. So the point is that those ratios, you can use those as conversion factors. Today, we're going to get more specifically into mass and using dimensional analysis, just like we've been doing, but converting from mass to moles. All right, so let's start this PowerPoint. After today, you'll be able to calculate the number of grams produced or reacted for a substance given a chemical equation. I'm hoping you guys can hear me. My microphone isn't the greatest. So yeah, we're going to be going from grams to moles to grams. All right. So we have 3 steps that are needed for you guys to do these calculations. The first step is to convert grams to moles. And you're going to use the molar mass from your periodic table of your known substance. So it's going to give you something in the question and you're going to convert that to moles. We've done that a lot. We did that in our chemical quantities unit over and over and over again. Okay. Step 2, we're going to convert all moles of our known to moles of our unknown, and we're going to use the mole ratio from the coefficients in the equation to do that. All right. And that's what we learned how to do yesterday, is converting moles to moles. All right. And then once we have the moles of our unknown, then we're going to use the molar mass of that to convert to grams. Okay. So step 1, grams to moles of our known. Step 2, moles to moles from our known to our unknown. And then step 3, moles of our unknown to grams of our unknown. Okay? All right, so let's do some examples. I think the easiest thing is to do some examples. What mass of silver chloride will react with 15 grams of aluminum? What's our known? If we look at this, our known is 15 grams of aluminum. So we know we have aluminum. And we're looking for silver chloride. Okay, so from those two um, reactants, sorry, from those two reactants, we can come up with some products. So we have aluminum and silver chloride. This will be a single place replacement reaction. If you look at your activity series, aluminum is more reactive than silver. It will replace it. So what we will get is silver and aluminum chloride. Okay, so we've got our equation written out, and now we have to balance it. Let's just review balancing, okay? So go ahead and if you need to, write out the elements that are present. So we have aluminum, we have silver, we have chloride on both sides of the equation. To start off, we have 1 of each of the aluminum, silver, and chloride on our reactant side. On our product side, we have 1 aluminum, 1 silver, but 3 chloride. So we have to do a little balancing here. We're going to put 3 in front of the silver chloride, and that will change our chlorides to 3 on our reactant side. It also changes our silver to 3 on our reactant side. So then we have to go back and add a 3 in front of our silver on our product side to change that. And now we are balanced. Okay, so now remember, when you're doing this yourself, you do not have to write a 1 as a coefficient. You can assume 1 if you don't have a coefficient. Okay, so we're given 15 grams of aluminum in our equation, and we first have to turn this to moles. So we're going to take our 15 grams of aluminum, and we're going to look at our periodic table, and aluminum has a molar mass of 26.98. So we're going to use that to get to moles, all right? And I'm going to do this all in one step because it's easier. So from here, we would be able to cross out our grams of aluminum. All right, now we have moles of aluminum, but we're looking for moles of silver chloride. So now we're going to use our mole ratio. We have 1 mole of aluminum for every 3 moles of silver chloride. We want to end up with the moles of silver chloride and cross off our aluminum. So the silver chloride is going to go on the top. So we have 3 moles of silver chloride for every 1 mole of aluminum. And now we can cross off our aluminum, okay? Now that we have our silver chloride right here, you guys can see that, we need to turn this into grams. So we're going to have to figure out the molar mass of silver chloride and use that in order to get that into grams. So silver is 107.871, okay? Chloride is 35.45. We add that together and we have a molar mass of 143.32 grams. So we're going to use that as our conversion factor. Now we can cross off our moles of silver chloride. So all of our units have canceled except for our grams of silver chloride, grams of silver chloride, which is what we wanted to end up with. It's exactly what we're supposed to have. So now we can do the math, and you should get, I don't know if you guys can see this, my screen might be a little bit in the way, but you would get 239 grams of silver chloride. All right. So this should look somewhat familiar. Oops, I'm going to go back for a second. This should look somewhat familiar. We've done all of these steps over and over in different units up to this point. This is the unit I was telling you where everything gets put together, okay? So the keys here is if you're struggling, if you can't work something out, make sure you've written out your chemical equation correctly, okay, to start off, and then always go to moles first, right? So it gives you grams, go to moles, okay? And then you can use your mole ratio and then go back to grams. Okay, let's do another example. What mass of oxygen gas would be produced from the decomposition? What mass of oxygen gas would be produced from the decomposition of 37.2 grams of lithium chlorate? Okay, so decomposition reaction, what happens? If you remember, when we have a chlorate that decomposes, we produce that metal chloride and oxygen gas. So we start with our lithium chlorate, and then that's going to decompose, remember? So it's going to react, and you're going to end up with lithium chloride and oxygen. Okay, so now we can balance this. Oops, now we can balance this. We're just going to have 2 lithium chlorates reacting to form 2 lithium chlorides and 3 oxygen gas. Okay, so now we have our balanced equation and we can start. It gave us in the question 37.2 grams of lithium chlorate. So that is what we're starting with, all right? And we're asking what mass of oxygen is going to be produced. So we're looking for oxygen. So the ratio we're going to use is this 2 to 3. Okay, 2 moles of lithium chlorate for every 3 moles of O2. Okay, so start off. We always start with what's given. We are given the 37.2 grams of lithium chlorate. All right. And we need to use the molar mass in order to turn that into moles. Oops. So 1 lithium atom has a 6.94 grams for its molar mass. Then we have chloride, it's 35.45 grams. And we have oxygen, which is 16, but we have 3 of those, so you have to multiply that by 3. You add all that together and you get 90.39 grams as the molar mass of lithium chlorate. So now we're going to plug that in, okay? Our lithium chlorate can go ahead and cross off, and so our grams of lithium chlorate. So now we have moles of lithium chlorate. we want to use this molar mass, right, or the mole ratio right here, the 2 to 3. Okay, so we're going to have 3 moles of O2 produced for every 2 moles of lithium chlorate used right here. Okay, that decomposes. So now our moles of lithium chlorate can cancel out, and we need our molar mass of oxygen to then um, convert to grams of oxygen. We have 32 because remember, oxygen is one of those diatomic elements, so it has 2 atoms. So 32 grams over 1 mole. Our moles of oxygen can cross out. You could do the math and you would end up with 19.8 grams of oxygen gas. So there we go. Let's just review really quick what we have to do. What are these steps? So the summary of important points. You are calculating the mass for 2 different substances. Okay, so you have to use 2 different molar masses when you're going from mass to mass. You start with the mass of the unknown. You use that molar mass to convert it to moles. Then you're going to use your mole ratio to get the moles of your unknown. And then you're going to use the molar mass of your unknown to convert to the mass of your unknown. All right. Your molar mass is always equal to 1 mole. I think you know this. We've gone over this over and over and over, but don't forget your molar mass is always equal to 1 mole. The only time that you're going to have a different number of moles is in that mole ratio itself. Otherwise, your molar mass is always equal to 1 mole. Okay. In the mole ratio, you're looking at the moles of reactants to products, or reactants to reactants, or products to products. Okay. So again, you're calculating the mass for 2 different substances. Your molar mass is always equal to 1 mole. And the only time the number of moles is different than 1 is when you're doing the mole ratio step. Okay. If you have questions or concerns, I know this can be a little bit confusing. And if you've struggled with any of these steps along the way, feel free to call me, text me. We can FaceTime, we can Zoom, and we can do a few more examples together. All right, you guys, I hope you have a fantastic day. And yeah, do the best you can. Don't forget, check out YouTube if you need some more videos. There's tons of stoichiometry helps out there. There's tons of resources. So just look some up and it will walk you through all of these steps as well. All right, you guys, see you later.